Assalamu alaikum. Our lesson today is about the cyclic quad. But as a first, we want to make a quick revision about some concepts about angle and at triangle. Here we have central angle POD, which it's measure 68, and inscribed angles, which it's measure half the central. And here we say that the measure of the arc PD equal the central. Why? Because if we get a protractor and put it here, there's a full protractor. If I put it 0, and here, for example, 100, so this is a measure of the arc. So measure of the arc equals the central, and the inscribed half is central. The inscribed half is central. Okay. And also, we want to mention about the inscribed angles subtended by the same arc. Subtended by the same arc. They always, forever equal in measure, because angle Q equal half the arc CD, and V also equal half the arc CD. Whatever happens, it will be equal half the same arc. So let's go back to our lesson today. What is a cyclic quad? Cyclic quad, we would say quad instead of quadrilateral, like abbreviation. It's a quadrilateral whose 4 vertices belong to one circle. How? Let's see here. A, B, C, D. The 4 vertices lie on the circle. So I can draw a circle passing through these 4 vertices. Let's see. And we found a point in the plane, all the 4 vertices in equal distance from it. This point will be the center of the circle passing through the vertices or the circumcircle. So in this figure, if we make it like this is cyclic quad. Why? Because if we put the sharp pen of sharp side of the compass here, we can make a circle passing through these vertices. So the first property of cyclic quad here, MA equal MB equal MC equal MD. So, and another property, we say here in the cyclic quadrilateral, each 2 opposite angles are. Let's see here. If we speak about opposite angles, A, its opposite is C. So he want to make out to find property between these 2 angles. So A equal half the arc PC. Let's make there is arc PC here. This is arc BD or BCD, and angle C subtended by arc DAB. So the sum of these 2 arcs equals 360. So A half the green arc and C half the red arc. So A plus C half more the circle, and the circle equals 360. Then the sum of A plus B equal 180. and the sum of 180, two angles, the sum 180, it means supplementary. It means supplementary angles. So here A, B, C, D is cyclic quad. If we see here, whatever we change the angles, the opposite angles, they sum up. The green angles, they sum 180, and also the red angles, they sum 180. And now let's try to solve some exercise here. Here we have D equal 86, and he want to find P. It is opposite angles, then they sum up to 180. So 180 minus 86, it will be 94. So this one, the measure is 94 degree. And here, what we can find here it is 64. So opposite to it is 180 minus 64. It will be 116. And in the triangle ADC, we have two angles. So we can find the third. It will be 180 minus 116 plus 34. It will be also 32. And here, another two questions. Here we have it is here 70. We want to find ABD. We want to find this one. So here I have a 70. The opposite to it will be supplementary of it. What is will be 110. 110, 30. Then the third angle in triangle ABD will be 40 degree. Here, he want to find measure of angle A. Here, A half is inscribed, half is central, which is 2x. So here is A. Here, A equal x. But he want the value of x. Here, I have A plus C. X plus 2x is 3x. Equal 180. Then 1x divided 3 will be equal 60 degree. And now we'll speak about the exterior angle of a cyclic quad. What is the exterior angle of any polygon? It is extension of a side. So measure angle CDE. CDE is exterior angle of the cyclic quad APCD. Whatever is extension. So let's try to find the relation between D and B. B always equal the exterior. Even it is changed, it will be changed also. Change with change with it. So we can say that the measure of the exterior angle, the measure of exterior angle at a vertex of a cyclic quad, like here, it is EBC, is equal to the measure of the interior angle at the opposite vertex. We speak about the vertex P, exterior at P, opposite to B is D. So here, measure of angle EBC equal measure of angle D. And let's use it to solve these problems together. Here, we say that find the question marks here. Here A, we have 110 is exterior angle of the cyclic quad as the vertex C, so it is equal interior opposite of this vertex. So E here would be equal 110. Here we have exterior equal opposite the vertex, so this one is 80. And here two opposite angles, their sum equal 180. Excellent. Then here it will be 104. And in the last one, here 75 is exterior of the cyclic quad, then it is equal opposite the vertex. So A here will be equal 75 degree, and here 75, and it is exterior equal 65, so it's also 65 degree. Here other property, it says that each two angles are drawn on the same base are equal in measure. Why? Because the inside the circle it will be inscribed. So if we take this circle away and try to find what is equal to measure of angle A subtended by the side or the base CB, who is it? It is angle 2. Excellent. Then 1 equal 2. And we want 5. Let's see 5. Here is 5. 5 subtended by the base AD. Who is with 5 here on CD? Just move it like that. It will be excellent. 6. And measure of angle 3. Ask me about angle 3. Angle 3. It's subtended by the base DC. Move it like that. So 3 will equal 4. And what about 7? 7 here. 7. 7 here subtended by AB. AB also will be 8. Will be angle 8. So let's try to solve these problems here. You want to find the question mark also, and he says that all of these quads are cyclic. A, B, C, D is a cyclic quad. Find the measure of the angle denoted by question mark. Here we have 32. 32 subtended by AB. With it, this one. So this one also is 32. Here, go to the second one. We have here 30. Subtended by the base AB. With it, this one. So This one will be equal 30 and the same 100. 100 here is not just this, it's all of this. So the opposite to it will be the opposite to it, which is all of the, it will be 80 supplementary of it. A part of it of 30, then the other part is 50 degree. And here, the third one, if I make the same, I go to one of the known 45 subtended by AB. So this one is also equal 25. 25. And if I go to the 65, subtended by AD, with it, this one. So this one also 65. If I go to the 44, the 44 is subtended by CD, with it, this one, which is A. So this one is also 44, 44 degree, and so on. And for this one, we'll get it from the triangle DBC, DBC. In triangle ADBC, sum of the angles equal 180. So it is 180 minus all the other angles, which is 65 and 25 and 44. That will be equal 46. So this one is 46. This one is 46. Subtended by CB, and this one also subtended by CB, it will be also equal 46. And as a summary of what we studied today, we have these cases. If all the points equidistant from a fixed point in the plane, so this point is the center of the circle, angles subtended by the same base are equal, so 1 equal 2, 3 will be equal 4, 5 equal 6, and so on. Here, the opposite angle are supplementary, their sum up to 180, and also exterior angle at a vertex equal the interior opposite to this vertex, and vice versa. What's the meaning of vice versa? If we want to prove a quad is a cyclic, we prove one of this property. And now let's try to solve one of the exams questions. Here, he says that ABCD is a cyclic quad in which AE ray bisect angle BAC, I put it here. It means 1 and 2 are equal. And DF bisects angle BDC, DF bisect angle BDC, which means angle 3 equal measure of angle 4. Proves that AEFD is cyclic quad. AEFD cyclic quad. He wants this one is cyclic. So here, since in the ABCD is cyclic quad, then measure angle BAC equal measure of angle BDC. Then half angle BAC, which is 2, equal half BDC, which is 3. Then 2 equals 3, and they are subtended by the same base, which is EF. Then AEFD is cyclic quad because 2 and 3 are equal. And the second required, you want EF parallel to PC. So from the previous, we have ABCD is cyclic quad. Then measure of angle 5 equal measure of angle 6. And from the cyclic quad, AEFD 6 equal subtended by DF is equal to 7. 5 equals 6 and 6 equals 7. Then 5 equals 7, and they are corresponding. Then EF parallel to PC. And now let's take a look for another question. Here he says that two intersecting circles at A and P, CD, passing through the point P, and intersecting the two circles at C and D, CE, intersect DF ray at X, proves that AFXE is cyclic. We want AFXE cyclic quad. So here, let's join AB. We will join AP. When we join AB, we make two cyclic quads. AFDB. In this one, measure of angle 1 as exterior equal measure of angle 2 as interior opposite to the vertex. Okay? And the 2 as exterior of the quad ABCE, 2 will be equal 3. And here, Allah, 1 equal 2 and 2 equals 3, then 1 equals 3, and 3 is exterior of the quad AFXE, then AFXE is cyclic quad. Thank you. And now we'll start to solve some questions. Here, first one, he said to me that EB and EC are two tangents to the circle M at P and C respectively. So two tangents from a point outside circle, so they are equal lengths. Since they are equal lengths, this angle measure is 45. That also is 45. Then the third angle is 90. And he said to me that if BC is equals to 3√2, he want me to find CE. Here we have 45, 45 triangle. From the trick, the ratio between sides is 1 to 1 √2. And here the hypotenuse is 3, so this triangle is multiplied by 3. So CE will be 3. So the answer here equal 3. Yeah. Our answer here is 3. Second one. With the same figure, he wants me to calculate measure of angle ABE. ABE. From the previous one, we say that is right angled, and here is 45. He wants me to calculate ABE. ABE, all of this one. So I need this, and I want to know this one first. Here we have A, B, C, D, cyclic quad. Opposite angles are supplementary. So measure of angle B will be 180. It will be 180 minus 68. The result will be 112. So here it will be 112. But you ask me about all of this one, ABE. So it will be 112 plus 45, 157. So my answer for the second one is 157 degree. And let's see the next one. The next questions, he asked me about the perimeter of triangle ABXC. Not the quad, ABXC, this quad. So the perimeter equals sum of the lengths of all sides. So what we have here, we have isosceles triangle, Z equal Y. Then here is 24, so here also is 24. Here also is 24. And C midpoint and P midpoint. Since this triangle is isosceles, then A and AX is perpendicular to the base. So it is bisect the base. So this one equals this one. And bisect the vertex also. This equal to this. So like that, we have that. P midpoint this, then this side is 12. And the C midpoint, this side is 12 also. And here, C midpoint and the E midpoint, then AC parallel to XZ and equal half XZ. So this also is 12. And AB, A midpoint and the B midpoint, then AB parallel to XY and equal half XY. So it is equal 12. So the perimeter here is 12 times 4. It will be equal 48 centimeter. So the answer here in this one is 48. Next one. Here he asked me about the proportion. He says that x over 3 equal y over 4 equal z over 6. Find 2x plus y minus 2z over 2y minus x. So I will make it like that. I will take the first ratio and multiply both of the undistant and consequence by 2. يبقى 2 by both sides of the ratio, up and down, plus second ratio minus 2 multiplied by the third ratio. And let's do it. It will be 2 up and down, the first. It will be 2x over 6 plus the second plus y plus 4 minus 2 third minus 2 the third 2z minus 12. It will be equal one of the ratios. Let's complete it. It will be 2x plus y minus 2z over negative 2. Just equal one of ratios. One of ours. And we'll do the same to get the denominator here. We'll take 2 by addition and consequence of the second ratio minus the first ratio. That will be equal. Give me that. To the first ratio. So to the second ratio. So it's 2y over 8 minus the first minus x minus 3 equal 2y minus x over 5. Also equal one is the ratio. Then 2x plus y minus 2z over negative 2 equal 2y minus x over 5, which gave me that 2x plus y minus 2z over, I will change this 2. So I will take this and this and down. It will be 2y minus x equal negative 2 over 5. So the answer of this one is negative 2 over 5. And let's take this, the next one. Okay, here, let's make some agreement first. You said to me that in the given figure, O is the origin. And the slope of BC, of the red one, is 1 over 3. So we know that the slope equal tan the opposite angle of, tan the angle with the positive direction of x-axis, which is this one. So I will say that measure of angle CBX will equal shift tan or tan minus 1 of 1 over root 3 equal, was calculator, shift 10 was calculator, shift 10 1 over root 3 which will be 30. So here it will be 30 degree. So here that is 30 degree. And from the second, from the equation of AC, the blue one, it said to me that x minus y equal 9. I like to make it like that. I like to put it in the form of y equal mx plus c. So if I take one y out and put 9 here, it will be y equal x minus 9. Here, the slope is 1, and the y-intercept is negative 9. Give to me the slope equal 1. Then, do a measure of angle CAX equal shift 10 minus 1 of 1, which is equal 45. So this one is 45 degree. Like this, I can make it like this. 45 is exterior of triangle APC. Then equals the sum of the two non-adjacent angles, 30 plus C. So if I want to get C will be 45 minus 30, which is 15 degree. So the answer of this one is 15. Let's go and take 15. Next questions. The next one. Here he says that if the rational number a over p is positive if. Okay. Here, to get a over p positive, we have two probabilities. First, negative over negative, b equal positive, or positive over positive, to the result to be also positive. So, which of this one give me both negative or both positive? A greater than b, a plus b equals 0, no. A, b less than 0, if I make it, so it is positive not less than 0. So, both negative a, so a times b, negative times negative will be positive, which is greater than 0. Positive by positive will be also positive. So the answer here is AB greater than B. And let's make it here. AB greater than 0. Next one. So here he says that the curve represents a function f of x equal negative x power 2 plus 4x plus k minus 2. This curve, since the coefficient of x squared is negative, so it is up and down. And he say also OB equals 3 OA. OB equals 3 OA. So let's do it like that. So OB equals 3 OA. So if this distance is x, so the point here is called what? Negative x and 0. And this 3x. So this point will be 3x and 0. So he asked me to find the value of k. So let's substitute with negative x and 0 in this function. And we'll say that f of negative x equal negative. Negative x power 2 is x power 2. Negative x by 4 is negative 4x. Excellent. Plus k minus 2. And let make that all, of course, equal 0. And substitute with 3x. It will be negative x to power 2. The 3x to power 2 will be 9x positive power 2. 4 by negative 4 by 3. It will be 12x plus k minus 2 equal 0. So here I want to find the value of x. If this one is equation number 1 and that is equation number 2, let's make that like this. By subtract 2 from 1, we'll get that. 8x to power 2 minus 16x, x minus k minus a is gone, negative 2 minus plus negative 2 is gone, equal 0. By taking out the highest common factor, where here is 8x, it will be x minus 2 equals 0. So here, like that, x equals 0. Refused, because x here is not 0. It is a length. Or x minus 2 equals 0. It means x equal 2. So we get x. We get x is 2. Let's substitute with it in the equation here. It will be f of 2 equal let's make it negative 2, because here the point will be negative 2 and 0, and here will be 6 and 0. When we put x with 2. So here it will be negative 2 to power 2 is 2, is 4. Negative 2 by 4 will be negative 8. Plus k minus 2 equals 0. When we solve it, we find k minus 12, k minus 14, k minus 14 equals 0. Then k equal 14. So the answer of this one, here he said that find the value of first one, find the value of k. K will be 14. K will be 14. And when k will be 14, the equation to become like that. Equation will be, if we substitute, if we put k 14, the equation will be f of x equal negative x to power 2 plus 4x, k14 minus 2, it will be 12. That is function, which we We'll complete with it. So we will complete using this function to find the equation of the line of symmetry and the vertex. Equation of line of symmetry is x equal negative b over 2a. Here, a, b, c. Here, a equal negative 1, b equal 4, c equal 12. Negative b, so it is negative 4 over 2 by negative 1. We'll finish it. It is x equal 2. That's the equation of the axis of symmetry. Find the point of vertex. Point of the vertex. We take this one and try to find f of 2, because the point of the vertex negative b over 2a, which we get it, and f of negative b over 2a, which we try to get it, equal, we substitute in this one. So negative 2 to power 2 is 4, plus 4 by 2 is 8, plus 12 equal 16. So the point of the vertex is 2 and 16. So here we get the axis of symmetry, x equal 2. Line of symmetry is x equal 2. And the vertex of the function is 2 and 16. So let's try the next question. And the next one, he says that R is a relation from X to Y, where R represents the function ARP, means A is factor of P. A is factor of P. And he says that X union Y is 4, 5, 7, 8, 13, 25, 49. Number of elements of X is 3. 3 elements at X. And the number of X product Y is 12. It means number of X is 3 and number of Y will be 4 elements. So here we want to find a factor of P. Let's try here. Here, if we get 4, 4 is factor of 8. And 4 factor of none one else. 25 factor of 7, 8, 5 factor of 25. 7 factor of, excellent, 49. 8 factor of none. 13 factor of none. 25 factor of none. 49 factor of none also. So the relation, find R. So here R equal 4 as the first projection, and 8, and 5, and 25, and 7, and 49. So that's R. And also he asked me about the range. The range is the set of the images, which is 8, 25, 49. 8, 25, 49. So the answer of these two questions will be 4 factor of and 7 factor of this one as and here the answer will be 82549 images. And let's try the last one. Here, as this one, I will use the number to make it easier in writing the proof. I will put here, let's call it 1, angle number 1, angle number 2, angle number 3, angle number 4, angle number 5, and here is number 6. And if I will use the method of numbering, I have to copy the figure in my answer sheet. And here, I will make congruent to the two triangles XYM and LMZ, and say that in two triangles XYM okay, and this triangle MZL. MZL. We have XY equal MZ, and the measure for angle Y equal measure of angle Z, and YM equal ZL here, which is the case of side angle, two sides and included angle. Then triangle XYM congruent to triangle MZL. Then measure of angle 1 equal measure of angle 3, and measure of angle 2 equal measure of angle 4, and XM equal ML. Since the measure of angle 1 plus 2 is the right angle triangle, then 1 plus 2 equal 180 minus 90. Measure of angle 1 plus measure of angle 2 equal 180 minus 90 degree, which is equal 90 degree. Then if we take off 1 and put 3 instead of it, it will be measure of angle 3, which is equal 1, plus measure of angle 2 equal 90 degree. And here we have supplementary angles. Then measure of angle XML equal 180 degree minus 90, which will be equal 90 degree. So that is will be 90 degree. So in triangle XLM, we have MX equal ML. Then we have isosceles. Then base angles, which is 5 and 6. Measure of angle 5 equal measure of angle 6. Each of them of measure 180 minus 90 all over 2, which is would be equal 45 degree. Then measure of angle MXL equal 45 degree. Thanks.